All right, so question 56. Gerald decided that this method was taking too long, that it was too confusing, and made too many mistakes. I agree, he missed a lot of stuff. Even if he listed all the combinations correctly, he still had to find the sums and then find the theoretical probability for each one. Inspired by a multiplication table, he decided to make sense of the problem by organizing the possibilities in a probability table like the one shown below. So if I look at this, I think here's what he has going on. It doesn't matter which one we're doing, but I'm going to say that these number going across would be like his first dice. All right. And then these numbers going up and down, we're going to call his second dice. And you can switch them. I don't think it really matters. All right, so that's kind of what this table is going. So if he rolled a 1, then that goes with this one. If he rolls, first dice. So he rolls a 1 on the first dice, he can get a 1 on the second dice. He rolls a 1, he can get a 2 on the second dice. A 1, he gets a 3, a 1, then a 4. So I think this does a better job of making sure that he doesn't miss any. So part A, how does Gerald's table represent the two events in this situation? So the two events would be, this would be like his first dice, and that would be his second dice, or you can call this his first dice, and these numbers his second dice. So that's the two events. What should go in the empty cells? So in these empty cells, I think these are the sums. So when he adds the two dice together, so here he rolled a 1 and a 1, so the sum is a 2. A 1 and a 2, so the sum is a 3. A 1 and a 3, so the sum is a 4. So in these spaces are going to be the sum of the dice added up. Discuss with your team and then complete Gerald's table on your own paper or explore using this student tool. So I would just do this on your paper, make this, and let's fill them in. So real quick, we're going to fill these in. That would be a 5. That would be a 6 and a 7. So a 2 and a 3 is a 5. A 2 and a 4 is a 6. We have 7. And then this here is going to be an 8. We have a 4 and a 5 and a 6. And there's a little pattern here. 7, 8, and then that will be a 9. All right. So this gives me a 5 and then a 6 when I add them up, and a 7 and an 8. Nice thing about math is you got these patterns that make life a lot easier. And then this here would give us a 10. Trust me, that's a 0. This is a 5. And then this would, okay, wait a second. That's not right. Take this out. And let's see. So 5 and 1 would make this a 6. And that makes that a 7. And that's an 8 and a 9 and a 10. And that makes this an 11. And let's see, 6 and 1. So that's a 7. And then an 8. And then a 9. A 10. An 11. And then a 12. All right, so that makes my table. So let's see, Gerald's table, draw on paper, and finish it. All right, so we finished that up. Part B, how many total possible out number combinations are there for rolling 2 cubes? Is each combination listed equally likely? That is a probability of getting 2 1s the same as getting 2 2s or a 3 and a 1? So I think the chance of getting a 1 and a 1 is let's see. There are there's 1, 2, 3, 4, 5, 6 this way. 1, 2, 3, 6 this way. So this is a 6 by 6 grid. So I bet you there's 36 numbers in here altogether. So out of 36, the chance of rolling a 1 and a 1 would be a 1 out of 36. The chance of rolling a 1 and a 2, I think, would also be a 1 out of 36. The chance of rolling a 1 and a 3 would be 1 out of 36. So I think that each of these has a 1 in 36 chance. So back to the question. How many total possible number combinations are there for rolling 2 cubes? So that would be, I think, 36 of them. Is each combination equally likely? I would say yes, 1 out of 36. So I think we answered B. Part C, how many ways are there to get each sum? Are there any numbers on the game board that are not possible? So all the different ways to get the different number of sums. All right, so hold on, I want to get this out of here. So let's organize our thoughts here a little bit. So I want to know for C, how many ways are there to get each sum? All right, so let's figure out all the different ways we could get a 1 for a sum, or all the different ways we can get a 2 for a sum, or a 3, or a 4, or a 5, and a 6, and a 7, 8, 9, 10, 11, and 12. All right, so we're going to find out how many different ways we can come up with our sums for this. So let's go to a different color here. I don't know, let's go to that. So how many different ways can I get a 1? Well, there's not a way to get a 1 if we're rolling 2 dice. So that would be 0 ways. All right, how many ways can we get a 2? Well, let's see, I see 1. I think there's only 1 way. All right, how many ways to get a 3? Well, there's 1 there. 2. Oh, that's the only one. 2. How many ways to get a 4? Well, there's 1, 2, 3. No, just 3 ways. Okay. How many ways to get a 5? Well, we've got 1, 2, 3, 4 different ways to get a 5. All right. How many ways to get a 6? So we got a 1, a 2, a 3, a 4, 5 ways. How many ways to get a 7? Well, we got 1, 2, 3, 4, 5, 6 different ways. And how many ways to get an 8? Well, nothing there. Then we have 1, 2, 3, 4, 5 different ways. All right. How many ways to get a 9? Nothing there, nothing there. Oh, there's a 9. So there's 1, 2, 3, 4 ways. All right. How many ways to get a 10? Oh, nothing, nothing. Can't get a 10 in that row. Oh, there's 1, 2, 3. All right. How many ways to get an 11? 1. I guess there's only 2 ways. And how many ways to get a 12? Well, there's only 1 way. All right. Well, I guess that would give me a better idea of what to choose for my O's. So how many ways are there to get each sum? Okay, we did that there. Are there any numbers on the game board that are not possible? Yeah, the only thing on our board that we could not get, because remember our numbers were, hold on, let me go back here real quick. Our numbers on our thing were 1 through 12. So the only number I couldn't get would be a 1. There's no possible way that I could ever get a 1. So how many ways did I get? We did that. Are there any numbers on the game board that are not possible to achieve? So to finish out part C, a 1 would be the only number that we can't achieve somehow. D, what is a theoretical probability for getting each sum listed? All right, well, let's think about this. So let's see, remember there are 36 different numbers in here, or 36 different sums in here. So I'm going to write this right next to it. I should probably go to a different color. Let's go green, I guess. So there's 36 numbers, so that's my fraction. And there are 0 out of 36 ways to get a 1. How many ways can I get a 2? Well, out of the 36 combinations, there's only 1 way to get it. So a 1 in 36 chance. For 3s, once again, there's 36 different numbers that we could get, and there's 2 ways to get that. And so I'm going to go and put all these over 36 because there's 36 different ways that we can come up with sums, and this was 3 of them. Out of this, there were 36 different ways we can get stuff. 4 of them were 5s. How can I get a 6? 36 different ways, and there were 5 of them. I wish I would have used a bigger piece of paper. Here, 36 different sums, and there's 6 different ways that we can get a 7. 36 different sums, and there's 5 ways that we can get an 8. Over here, 36 different ways, and 4 of them was a 9. So different ways to get a 10. Well, there's 36 different combinations. 3 of them were a 10. 2 out of 36 ways to get an 11, and 1 out of 36 ways to get a 12. All right. Well, when I look at this, I guess 7 would have been my best number to go with. And there were quite a few 7s I came up with. That's my best number I should have chose. All right. So what's the theoretical probability? Well, there they are. The stuff in green is my theoretical probability. Now work with your team to determine a better strategy for Gerald to place 10 O's on the board that you think will help him win. Explain your strategy and your reasoning. Well, if I was going to place 10 O's, I think what I would probably want to do is put most of my chips on the 5, 6, 7, 8, and maybe the 9. So I guess I would probably put, on my board, I got 10 chips. I would place all 10 of them on the numbers 5, 6, 7, 8, and 9. And I would probably place like most of them on the 7 because that has the best chance. So I might put like, boy, I don't know what I might do. If I was putting chips, I would probably put like 4 of them here. Maybe 5, maybe not 4. That might be too many. I don't know. I might place like at least 3 of them here because that's going to happen the most. Maybe 2 on this spot. 2 on this spot. Nah, I need more. I think I want 4. Yeah. So let's take that off. Let's put 4 on the most obvious one. So I would probably put 4 of them here, 5 of them here. Well, that only puts 1 here. Boy, I really don't like the way I got to split this up. I don't know. 4, maybe 3. Yeah, I like this better. 3. So I'm at 7, 8, 9, 10. I don't know if that'd work or not, but I think those would give me the best chances. Maybe I only put 3 here, 2 here, 2 here, and then put some on the 5, some on the 4. I don't think I would put anything on these or these because those are not very likely. So that would be my strategy. Yeah, I think that's probably what I would do. Hopefully this makes a little bit of sense. We kind of walked our way through it and we found out that our best chance is in here. These are if I have 2 dice, getting a 7 has the most ways that I could actually get a 7. I never realized that before.